This video will cover the ESP32, one of the most popular microcontrollers for IoT and embedded projects. The ESP32 is a microcontroller chip designed and manufactured by Espressif Systems, a company known for creating low-cost wireless communication for embedded systems and Internet of Things, IoT applications. The ESP32 itself is a major upgrade over earlier versions. It combines a powerful dual-core processor, built-in Wi-Fi, and Bluetooth connectivity all in a single compact chip. This makes it extremely popular among hobbyists, engineers, and product developers who are building smart devices, automation systems, or wireless sensors. One of the key reasons the ESP32 is so widely used is its flexibility. It can be programmed using different environments like the Arduino IDE, MicroPython, or Espressif's own development framework. This means beginners can get started easily, while advanced developers still have full control over low-level hardware features. In a home environment, the ESP32 is often used as the brain of smart systems. For example, it can be used in smart lighting setups where you can turn lights on or off using your phone. It can also help detect temperature, humidity, or motion, helping automate things like fans, air conditioners, or security alerts. In robotics, the ESP32 often acts as the main control brain of a robot. It takes input from different sensors, processes the data, and then sends signals to motors or other components to make the robot move or react. The ESP32 can detect obstacles and decide whether the robot should stop, turn, or change direction. In wearable devices, the ESP32 is often used as the main processing unit that connects devices, processes data, and sends information to a phone or other device. Since wearables are usually worn on the body, like smartbands, watches, or health trackers, power efficiency and size are very important, and the ESP32 fits well for many DIY and prototype designs. In logistics, the ESP32 is often used to help track and manage goods as they move through warehouses, delivery trucks, and distribution centers. Because it supports Wi-Fi and Bluetooth, it can send and receive data instantly, which is important for keeping information about packages and inventory always up to date. In home and commercial appliances, the ESP32 often acts as the control system that makes devices smarter and more efficient. Instead of appliances working in a simple on-off way, the ESP32 allows them to respond to conditions, user input, or automation rules. The ESP32 is also widely used in automation systems, making it one of the most versatile microcontrollers for both homes and industries. In automation, the ESP32 acts as the central controller, receiving input and sending commands to machines, devices, or systems to perform tasks automatically. Now we're moving into the hardware details. The ESP32 has multiple general-purpose digital pins that can be configured as inputs or outputs. These pins can read digital signals from switches, buttons, or sensors, and can also control devices like LEDs, relays, or motors. The ESP32 comes with a reset button, usually labeled EN or RST on development boards. This button is a simple but essential feature that allows you to restart the microcontroller without disconnecting power. When you press the reset button, the ESP32 restarts its program from the beginning, similar to rebooting a computer. The development board also includes a micro USB port, which serves several important purposes. This small connector is more than just a way to supply power. It's a critical interface for programming, communication, and powering the board. A boot button, often labeled boot or IO0, which plays an important role in programming the microcontroller. The primary purpose of the boot button is to put the ESP32 into flash mode. Flash mode allows the board to receive new programs from your computer via the micro USB port. When you press and hold the boot button while uploading code, the ESP32 is ready to accept the new program. A USB to CAN bridge is a device that allows a computer, via USB, to communicate with CAN networks, which are widely used in automotive, industrial, and automation systems. While the ESP32 doesn't have a built-in CAN interface by default, it can interface with a CAN bus using external transceivers, and a USB to CAN bridge helps connect these systems to PC for development, monitoring, or debugging. On most ESP32 development boards, there are two sets of I/O connectors, one on the top and one on the bottom of the board. The bottom set of I/O connectors provides access to additional general-purpose input-output (GPIO) pins as well as specialized functions, making the ESP32 extremely versatile for connecting multiple sensors, actuators, and modules. ESP32 Athena is a software platform designed to make developing advanced IoT and embedded applications on the ESP32 easier and more efficient. It provides tools, libraries, and pre-configured frameworks that help developers quickly build applications without starting entirely from scratch. The ESP32 is a compact Wi-Fi and Bluetooth-enabled module based on the ESP32 microcontroller, developed by Espressif Systems. It combines the processing power of the ESP32 chip with onboard flash memory and all the components needed to connect to wireless networks, making it ideal for IoT, embedded systems, and smart devices. The ESP32 is primarily programmed using C and C++, which are supported in frameworks like the Arduino IDE and Espressif's ESP32. These languages give developers low-level control, efficiency, and flexibility to interact with hardware, manage memory, and handle real-time tasks. To start working with the ESP32, you'll need a few essential hardware components. First is the ESP32 board itself, which is the brain of your project, with built-in Wi-Fi, Bluetooth, and GPIO pins. You'll also need a USB cable. This powers the board and lets you upload your programs from a computer. For building circuits, a breadboard is very useful, letting you connect components without soldering. You'll also need jumper wires to make connections between the ESP32, sensors, and other modules. Simple resistors are essential to protect LEDs or sensors from too much current. Finally, a reliable power supply is crucial if you want to run the ESP32 outside your computer, whether it's a battery pack or a regulated adapter. This keeps your project stable. In addition to the essential hardware, there are several optional components that expand what your ESP32 can do. A camera module lets your ESP32 capture images or stream video, perfect for security systems or robotics projects. Stepper motors provide precise motion control, and with a motor driver, you can safely control these motors for robots, automation systems, or smart appliances. A relay board allows your ESP32 to control high-voltage devices like lights, fans, or pumps, bridging the gap between low-voltage microcontrollers and household appliances. For projects that generate heat, a cooling fan helps keep your ESP32 and other electronics safe and stable. Finally, an RFID module enables wireless identification and access control, useful for smart home doors, inventory systems, or personalized automation. Using these optional components, your ESP32 projects can go from simple prototypes to fully interactive, real-world IoT systems. Getting started with the ESP32 is simple. First, connect your ESP32 board to your PC using a USB cable. Then, install the Arduino IDE if you haven't already. It's the software we'll use to write and upload code. Next, add the ESP32 board package in the Arduino IDE through the board's manager, so your IDE knows how to communicate with the ESP32. After that, select the correct ESP32 board model and COM port from the Tools menu. Finally, you can test your setup using the serial monitor. Upload a simple program, like blinking an LED or printing text, and check the monitor to ensure your ESP32 is working correctly. Once this is done, your board is ready for any project you want to build. Once your ESP32 is connected and set up in the Arduino IDE, it's time to write your first C++ program. A classic starting point is the blink program, which makes an LED turn on and off repeatedly. To do this, connect an LED to one of the ESP32's GPIO pins with a resistor, and make sure the board is powered via USB. In the Arduino IDE, you write a simple C++ program with two main functions: setup, which runs once to configure the pin as an output, and loop, which repeats continuously to turn the LED on, wait, turn it off, and wait again. After uploading the code, the LED will blink, showing that your hardware and software are working together. This small program is the foundation for all ESP32 projects. To wrap up, the ESP32 is a powerful microcontroller that combines Wi-Fi, Bluetooth, and a variety of input-output options, making it ideal for home automation, robotics, wearables, logistics, and more. With just a few essential components, like the board, USB cable, you can start creating smart projects. By learning to program it in C and C++, and exploring optional modules like cameras, motors, or RFID, the possibilities are endless.